Well, hey kids, just got home from school. And guess what I'm doing? More work. Oh my God. You wonder how I do it. I wonder too. Anyway, practice number 5. I know you guys are sick of my coffee jokes. They never get old. www.nkinfinity.com. Click on that. That's where you're going to find all of our stuff. I know it says under construction. I don't know if it'll ever be right because you know why? I'm a perfectionist. I hate not having stuff right. There it is. nkinfinity.com. Click on this. Click on review. Right? We're doing practice tests. Here we are. We're on number 5. You should be able to download this, print it, try it on your own. If you're here just to watch me perform like a trained monkey, you're in the wrong place. Well, that was pretty good. Let's get started to rock and roll. One of your flashcards, if you got the flashcards, is what is sine squared plus cosine squared. You need to know that. One of the other flashcards is what is 1 minus 2 sine squared. You need to know that. Now, sine squared plus cosine squared is 1. Wow, that's awesome. 1 minus sine squared is cosine squared. Well, wait a second. 1 over cosine squared is just the reciprocal function secant x. There it is, secant squared x. Now, having said that, if you're a quitter, you just quit and guess. If you're not a quitter, what you do is you say, I know, Mr. Krause taught me some strategies. Let me come up with an angle like 30.5. And we're going to store that into x. And then I'm going to type in my original function. My original function was, now putting these in is a little bit tricky. Sine of x squared plus cosine of x squared all over 1 minus sine of x squared. Now, if you type that in, you get some obnoxious number like 1.3467. Say, what? And then you try the answers like secant of x, forgot my parentheses, squared. Oh, look. Exact same answer. Try it. Try it. Now, I want you to notice the difference between that and this. Secant of x squared. Oh, it's the same thing. Oh, it redid it for us. So it understands the difference. It actually understands the difference. So maybe I didn't need those extra set of parentheses. I don't know. Better to be safe than sorry. Let's move. Which statement about the graph of e to the x is not true? So some of you think that e is like this some nebulous, crazy, we don't know what it is thing. So it's not. It's not. We'll get rid of this. Always start with a fresh graph. And you type in right over here. Do you see where my little shiny thing is? Right over there off the left side? That's the E button. Click on that and then click on X. E to the X. Enter. That's what the E to the X graph looks like. Simple exponential function. All exponential functions go through 0, 1. So it is asymptotic to the x-axis. Oh, does that mean it approaches the x-axis and does not cross it? Absolutely. Its domain is the set of all real numbers. Does it go forever and ever to the left and ever to the right? Absolutely. It lies in quadrants 1 and 2. It's over here in 2. It's over here in 1. Absolutely. It passes through the point E1. Now remember, this is my x value. This is my y value. So y equals e to the e. Does that equal 1? Who the heck would ever do e to the e? E to the 1 is e. It does go through the point 1 comma e. Remember, anytime you're doing exponentials, if you plug in 1, this will give you the base. So there is the wrong answer, which is the right answer for this question, which is not the right. It's wrong. It's wrong because it's not true. You got it. You get it? Okay, I got to go. All right, I'm going to show you the hard. Maybe I'm just going to do that. I'm going to show you the hard way to do this problem and then the easy way to do this problem. Let's do it the hard way. The hard way is just to look at the discriminant, b squared minus 4ac. If that is equal to 0, the roots are rational, equal, and real. Real, rational, and equal. If it's less than 0, it's imaginary. Now, if it's greater than 0, we got some issues. So if it's greater than 0, it's either going to be real and irrational or real, and this should also say unequal. Real, rational, it's either one of those if it's greater than 0. All right, so that's our thing. This is if it equals 0. No, this is if it's, oh, man. Come on, Krause. Need some more coffee. Oh, okay. Scratch. Back up. I wish I could erase everything. This is when it's less than 0. This is when it's equal to 0. This is when it's greater than 0 and greater than 0. But how do I know the difference? This one, because it's rational, would be a perfect square, like 25, 36, 49, 9, things like that. So let's see what's going on. We got 100 minus 4 times 1 times 25. And if I type that in my calculator, I get 0 out. So the big winner is not that one. The big winner is this one, real, rational, and equal. All right, moving on. A dartboard is shown below. In the two lines intersect at the center, and the central angle for 2 is 2 pi over 3. So this is 2 pi over 3. And we know that 180 degrees is pi. So this must be 1 pi over 3, because 2 pi over 3 and 1 pi over 3 add up to 3 pi over 3, which is just pi. So I know then that this area is pi over 3. This area is 2 pi over 3. This is pi over 3. And this is 2 pi over 3. So what's the question? If a dart is thrown at the room and equally likely to end anywhere on the board, what is the probability that a dart hits the board and will land in either, not wither, either sector 1 or sector 3? So that's the probability of sector 1 plus the probability of sector 2. So, yeah. Let's see what we got here. If we just get rid of the pi's, I think we'll be in good shape. Because, well, first of all, what represents the whole thing? Well, the thing that represents everything is 2 pi. So the whole thing is 2 pi. Now, if I just take these pieces, that's 1 or 3, right? Sector 1 or sector 3. So if I add those up, that gives me pi over 3 plus pi over 3. So this becomes 2 pi over 3 all over 2 pi over 1, multiply by 1 over 2 pi. 2 pi's cancel, and I end up with 1/3. Now that's the really complicated way to do it. If this is 2/3 and this is 2/3, don't these two have to make up also 2/3? Right? So in other words, this is 1/3 of the circle, this is 1/3 of the circle, and this is 1/3 of the whole circle. So the probability that it would land in there would be also 1/3. Another way to think about it is if I break it up into pieces. This would be 2 pieces, this would be 1 piece, this would be 2 pieces, this would be 1 piece. Because if this is 2 pi over 3, this is just half of that, which would be pi over 3. And that means if I add these up, that's 2 out of a total of 6. Anyway, 1/3 is the answer. Subtracted from, be careful with this, it's backwards. I don't even know why this is on here. This is like a course 1 topic. So we're going to take these and we're going to subtract these. So 5 halves minus 3 halves is 2 halves, which leaves me just x squared. How many of them have just x squared? Just 2. And then negative 3/4 minus 1/4. So negative 3/4 x minus 1/4 minus negative 1/4 x. So it's really a plus. So 3/4 plus 1/4 is 2/4, which is really 1/2 x. Negative 1/2 x. There's the big winner. And if you take 1 and you subtract off -4, you get 5. Actually, that would be the easiest place to start, right? Because if you do that, you're done. 1 minus 4 minus -4 is 5, and you're finished. All right. Finally, this one. I'm going to show you. Oh, hold on. I'm going to come back. So I'm going to show you a couple of different ways to do this. The first way, I'm just going to go the straightforward way. We're going to bring the 10 over. X squared minus 3x minus 10 is greater than 0. Now, you got to understand that greater than 0 means positive. That's all it means. Or above x axis. So, factor this puppy. I almost said a word that sounded like a swear word. So I didn't swear. I was trying to say puppy. X and x minus 5 and plus 2. Just factor it, straightforward factoring. So my two critical numbers are x equals 5 and x equals -2. Those are going to give me my testing zones. Now, I should have known it was 2 and 5 just looking at these over here, right? So, -2 and 5. Can I narrow this down at all? -2 and 5? -2 and 5, I don't know what this is. -2 and 5, so it's got to be one of these two. Now, this one represents connecting the dots. This one represents arrows going in either direction. So we need to know, is it going to do this? In which case, I want greater than 0. Or is it going to do this? Now, what do I mean by that? You'll see. Let's go to the graphing calculator. And let's graph x squared minus 3x minus 10. Enter. All right, so I want where it's above the x-axis. So that means from here, -2 out, and from 5 out. So from -2 out, and from 5 out. I don't want to connect the dots. So in this case, the right answer, the correct answer is choice 3. I want to the left and right. Now, how else could I have done that? Well, I could have also done it this way. This is a much faster way to get this one done, actually. You're going to graph it as two things. X squared minus 3x. Enter. And then tab, and then type in 10. Now, you can't really see it. You have to drag it down, right? So where is it greater than 10? Well, it's greater than 10 starting here. Well, if you do an intersection point, there it is. They connect the dots at 10. So where is it less? Where is it greater than 10? It's greater than 10 to the left of -2. And this one would be 5, and it would be greater than 10, greater to the 5, right? A 5. All right, that's another way to do it. All right, so, wow, here we go again. This negative means we're going to take this x over 1, and we're going to flip it and make it 1 over x to the positive 2/5. That's all we did. Well, this is really 1 to the 2/5, which is just 1, x to the 2/5. Now, that's not one of the answers. Second part you have to remember is this right here is a root. As I like to tell my kids, if this is the ground, and this is the tree you just planted, here's are the roots. The roots are in the ground. These are the, let's do it in the big, bold black letters. These are the roots. They are in the ground. Therefore, the root is in the ground. So I'm looking for a 5th root of x squared. It's in the denominator, so I'm looking for 1 over the 5th root of x squared. There she is, kids. There she is. All right. Holy mackerel. So here's the problem with this one. We're not really supposed to have radicals in the denominator. So more than likely, all they did was simplify by rationalizing the denominator. My guess is we're just going to do this. You're going to multiply by 2. Oops, excuse me. You're going to multiply by this radical, which is x plus 2 square root of x plus 2. All right, so by doing this, what we end up doing is In the numerator, I get 2x plus 4 times the square root of x plus 2 all over. Now, the square root of x plus 2 times the square root of x plus 2, think about it as the square root of x times the square root of x. Isn't that just x? Well, it doesn't matter if I do x plus 2, x plus 2. The square roots just cancel each other out, and I get an x plus 2. Now, you might be inclined to choose that as your solution, but you'd be wrong. Well, actually, none of those are choices. I would have put in simplest form, and then I would have made that a plus and watch kids grab it because it's wrong. What can I take out of these two? Oh, I can take out a 2. X plus 2. Oh, wait. Now that x plus 2 cancels with that x plus 2, and I'm left with 2 square roots of x plus 2. Again, take x, take 3.4 and stow it into x. Type this in, and you will get the same exact answer. The minimum point on the graph f of negative. So the easiest minimum point probably to make is like a parabola. -1, -3. That's the minimum point. Now, if I just say, okay, there's my parabola, you know, I can do a absolute value bar, absolute value graph too. It really doesn't matter. So what does this mean we're doing? By adding 5 on the outside, we are saying we are going up 5. So let me get rid of the blue one. So if I'm going up 5, 1, 2, 3, 4, 5. That's all I'm doing is going up 5. You're sliding that thing up 5. So my new minimum will be -1 doesn't change, and add 5 to this, you get +2. -1 + 2. On this one, again, I would stow these in and check it. But this could be a part 2, so you got to know how to do it by part 2. One of my fellow teachers just gave me a gift card to Dunkin' Donuts. Thank you. Thank you, thank you, thank you. I don't think I need any more coffee, though, do you? I think I got some on my nose. Anyway, 9 is 3 squared. So what we're going to try to do is get this thing to the same bases. The base is going to be 3. So 3x plus 1 equals 3 cubed x plus 2. Now, the way this works is, now that the bases are the same, as long as these exponents are going to be the same, then they're equivalent. So remember, let's see, what do I got to do? When I have an exponent raised to an exponent, oh yeah, we multiply the exponents. Don't forget to distribute. 6x plus 2 equals 3x plus 6. Distribute, 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 distribute. All right, bring this 3x over. I get 3x equals, so I'm going to subtract 3x. Subtract 2, I get 4. Divide by 3, I get 4/3. Ka-ching, there she is, the winner, 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 chicken dinner. Why am I talking like a whack job? This is what happens when you teach all day. Oh my goodness, check this out. This is crazy easy. What? Look at this problem. If you were looking at this problem, the first thing you should point your eyes to is that thing. What is that thing? What? This should send up alerts in your head. Now, why should it send up alerts? Because we are normally used to looking at it like this. 2y minus 6. That's normal. That's completely normal. Unlike me, if you know what I mean. This is backwards. Now, in my class, I don't know about your class or your teacher, but in my class, I give this the official word, the official name, the -1 rule. It sounds really official. It's called the -1 rule for a reason. It's backwards. Wait, no. Let's talk about it. So, let's not mess with this first one. It's 3y over 2, and I'm going to write it as y minus 6 plus. This thing is backwards. I don't like it backwards, so I am going to turn it around like that. Now, that's not that legal, except it is if you introduce a negative. For example, if I put a negative out front here, negative 2y minus 6. If I just take out the negative, I distribute that negative, I end up with negative 2y plus 6. Well, isn't that what that really is right there? Oh, yeah. Now, when I introduce the negative, I don't put the negative in the denominator because we don't like negatives in the denominator. I put it in the numerator. So minus 9. So that's why I call it the -1 rule. If you see something that's backwards, you can, if it's subtraction, this is only for subtraction. If you see one of the binomial is backwards for subtraction, turn it around and introduce a negative, and the negative goes up there. Well, now look at it. Now it's like, whoa, this isn't bad. I got the same denominator. My denominator is 2y minus 6. My numerator is 3y minus 9. I'm done. Come over and pick this one. And you'd be wrong. And you'd be wrong. And you'd be wrong. Or would you? See, there's a key word in this problem, and this is why they get away with it. It's this one right here, simplest form. Believe it or not, even though you've done all this really cool work and you checked it and it worked perfectly, you're not done. And that's because in the numerator, I can take out a 3. I'm left with y minus 3. In the denominator, I can take out a 2. I'm left with y minus 3. Gone, gone. There's your answer. 3/2. So, even though you typed in a number and typed this in, and typed in a number and typed that in, you got the same number. But is the number you got 3/2? Oh, yes, it is, because it doesn't matter what you put in for y, it will be 3/2. So the answer is choice 3. Which graph represents a one-to-one function? Man, we're going to end on an easy one. And a one-to-one function will pass the horizontal line test and the vertical line test. Now let's go through which ones are functions. This is a function. This is a function. This is a function. Not a function, because this fails the vertical line test. Boom, gone. Now let's check the horizontal line test. Fail, gone. Ooh, pass, pass. That looks like it. Look at this one. Fails, 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 fails. A horizontal line test can't pass the horizontal line test. There's your big winner. Yes, we're done with the multiple choice. Hit subscribe, hit like, send me a message. What do you want to see? Live. Oh, I'm hoping to get it done. Keep crossing my fingers. I'm going to send out a live, review session at some point. All right, kids, check the website. If you check over there, by the way, I added a bunch of new documents. You'll see if you click on Regents Review Topics, I added a bunch in here. Notice the videos aren't done because there's just not enough time in the day. I'm working on it slowly. Goodbye.